In 1922, archaeologist Howard Carter breached a sealed entrance in the Valley of the Kings near Luxor, Egypt. Inside the tomb of Pharaoh Tutankhamun, he discovered gold, jewels, and furniture that had remained undisturbed for more than 3,000 years. Yet among all that immense treasure, his team found something even more peculiar. Sealed inside alabaster jars and buried beside the deceased king as if it were as precious as gold itself, was honey. When they opened those jars, the honey was still perfectly edible. Even after 3,000 years, you could have spread it on a piece of toast. Every other food on the planet eventually rots. Bread grows mold, meat decays, fruit turns to mush within a matter of weeks. But honey just sits there as centuries pass and empires collapse around it, refusing to go bad. So how does a substance created by insects outlast entire civilizations? And how did this sticky golden liquid become one of the most valued substances in human history? The answer to that begins long before the pharaohs and long before Egypt even existed as a civilization. In 1921, a year before Carter discovered Tutankhamun's tomb, a group of researchers exploring a limestone cave near Valencia, Spain, found something painted on the rock wall. The painting depicted a human figure clinging to the side of a cliff, reaching into a hole in the rock face, while a swarm of bees circled around them. In their other hand, they held a basket. They were collecting honeycomb, and they had clearly climbed a very long way to obtain it. That cave painting, found at a site called Cueva de la Araña, which translates to Cave of the Spider, is roughly 8,000 years old. It is one of the earliest known depictions of humans interacting with bees. It tells us something vital. Before we had agriculture, before we had writing, and before we had metal tools, pottery, or permanent settlements, we were already risking our lives climbing cliff faces for honey. Similar rock art has been found in southern Africa, India, and Australia. Across every continent where bees existed, early humans independently figured out the same thing. Whatever was inside those hives was worth the pain of being stung dozens or even hundreds of times. Humans were not the only species that recognized the value of honey. Across sub-Saharan Africa, a small brown bird called the greater honey guide developed one of the strangest partnerships in the animal kingdom. A partnership that has lasted tens of thousands of years. The bird would locate a wild beehive high in a tree or inside a rock crevice, and then deliberately seek out a human. It would call out with a specific chattering sound, flutter from branch to branch, and lead the person directly to the hive. The human would follow, build a fire, use the smoke to calm the bees, crack open the hive, and take the honey. Then they would leave the wax and larvae behind for the bird. This was not a trained behavior. It was a relationship that evolved through natural selection over an enormous span of time between two completely different species, built entirely around one substance. For early humans, honey was quite literally irreplaceable. It was the only concentrated source of sweetness available anywhere in the natural world. Ripe fruit offered some sugar, but it was seasonal, unpredictable, and diluted with water and fiber. Roots and tubers provided starch that the body could convert to glucose, but the process was slow and inefficient. Honey was different. It delivered pure, concentrated, immediately available energy in a compact package that did not spoil. It could be found year-round in tropical and temperate climates and stored safely for months without any preservation effort. It provided an incredibly dense burst of calories, and the effort required to harvest it, climbing trees and cliff faces, enduring hundreds of stings, and smoking out aggressive colonies, was worth every second of pain. Anthropologists believe that honey may have played a direct role in human brain development. Our brains consume roughly 20% of our total daily caloric intake, despite making up only about 2% of our body weight. The glucose in honey would have been one of the most efficient fuel sources available to early hominids. Some researchers have even proposed that reliable access to honey helped push our ancestors toward larger, more energy-demanding brains over hundreds of thousands of years. If that theory holds up, honey did not just feed us. It may have helped make us who we are. But collecting wild honey was dangerous and unpredictable work. You had to find the hive first, figure out how to reach it, and then endure the fury of thousands of defensive bees. At some point, someone figured out there had to be a better way. The ancient Egyptians were the ones who cracked it roughly 4,500 years ago. Along the fertile banks of the Nile River, Egyptian beekeepers built cylindrical clay hives, stacking them horizontally in rows that looked almost like wine racks or clay pipes. These hives were designed to mimic the hollow logs and rock crevices where wild bees naturally nested, and the bees moved in willingly. What made the Egyptian approach remarkable was its scale and sophistication. Some beekeepers loaded their hives onto barges and floated them up and down the Nile, following the seasonal bloom of wildflowers so their bees always had fresh pollen to work with. This was organized, deliberate, commercial beekeeping, and it was happening more than 2,000 years before the Roman Empire existed. Honey in Egypt was not just food, it operated as currency, medicine, and sacred offering all at once. Workers at construction sites, including the laborers who built the Great Pyramids at Giza, were sometimes paid in jars of honey. Egyptian physicians used it to treat wounds, mixing it with animal grease and plant fibers to create bandages that modern researchers have confirmed were surprisingly effective. Medical texts written on papyrus scrolls, some dating back to roughly 1,500 years before the Common Era, list honey as an ingredient in over 500 different remedies. They prescribed it for eye infections, stomach ailments, burns, skin diseases, and surgical wounds. Modern science has validated many of these treatments, as honey has genuine, measurable antibacterial properties. The Egyptians figured this out through trial, error, and observation thousands of years before anyone understood what a bacterium even was. Then there was the religious dimension. Egyptians offered jars of honey to their gods, particularly to Min, the god of fertility, and to Ra, the sun god. The bee itself became a royal symbol, woven into the fabric of Egyptian identity. The pharaoh's formal title included the phrase, "He of the sedge and the bee," linking the ruler of all Egypt directly to this tiny insect. When a pharaoh died, honey was placed in the burial tomb alongside gold, precious stones, and weapons because the Egyptians believed the afterlife required sustenance. And if you were going to eat for eternity, you wanted something that would last forever. As it turns out, they chose the one food on earth that actually could. Egypt was far from the only ancient civilization captivated by honey. Travel east to ancient India, and honey appears throughout the Vedas, sacred Hindu texts dating back roughly 3,000 years. Ayurvedic practitioners prescribed honey for digestive problems, respiratory infections, and wound care. In Hindu mythology, the god Vishnu was often depicted as a bee resting on a lotus flower, and the god Krishna was frequently associated with the color of dark honey. Travel further east to China, and honey shows up in medical texts from the Han Dynasty, roughly 2,000 years ago, recommended as a treatment for fatigue, chronic pain, and poisoning. The legendary Chinese physician Shen Nong reportedly classified honey as a superior medicine, meaning it could be taken long-term without harmful side effects. But it was in ancient Greece where the cultural obsession with honey reached its peak. The Greeks believed bees were messengers from the gods. They called honey the food of the divine and associated it with wisdom, eloquence, and immortality. The oracle at Delphi, the most important religious site in the entire Greek world, was sometimes referred to as the bee. Priestesses who served at the temple were called melissae, a word that literally translates to honeybees. Newborn babies were anointed with honey, and the dead were sometimes preserved in it. Honey touched every stage of a Greek life. Aristotle, one of the greatest thinkers in human history, spent years carefully observing bee colonies and documenting their behavior. His observations were not always accurate. He believed the queen bee was actually a male king, for example. But his writings represented one of the earliest attempts at systematic biological study. The fact that he chose bees as his subject tells you how central they were to Greek intellectual life. Athletes competing in the ancient Olympic Games ate honey before their events as an energy source, a practice that modern sports nutrition has essentially validated. Soldiers carried honeycombs into battle, and Hippocrates, the father of Western medicine, prescribed honey for fevers, wounds, and ulcers. When Hippocrates wrote that honey cleans sores and ulcers, softens hard ulcers of the lips, and heals running sore, he was writing a medical recommendation that wound care specialists in modern hospitals would still largely agree with today. The Romans inherited the Greek obsession with honey, and being Romans, they industrialized it. Wealthy Roman estates maintained large apiaries with hundreds of hives. Beekeeping became a respected branch of agriculture, written about by scholars and practiced by landowners across the empire. Virgil, arguably Rome's greatest poet, devoted the entire fourth book of his Georgics to bees. He described their colonies with a reverence that bordered on worship, comparing the hive to an ideal society, disciplined, productive, and selflessly devoted to the common good. Roman soldiers used honey to preserve fruit during long military campaigns. Wealthy Romans poured it over roasted game, mixed it into spiced wine, and used it as the primary sweetener in virtually all of their cooking. Refined sugar from sugar cane would not arrive in Europe for another 1,000 years. Until then, honey was the only option. Throughout all of this, across thousands of years and dozens of civilizations, one strange fact remained constant. Honey never spoiled. Not in Egyptian tombs, not in Greek amphoras sealed with wax, and not in Roman cellars. People noticed this and relied on it, but nobody could explain why. That explanation would take roughly 2,000 more years and the invention of modern chemistry. The science behind honey's bizarre immortality comes down to four properties working together. Each one on its own would be impressive. Combined, they make honey nearly indestructible. First is moisture content. Honey contains less than 18% water. That number is critical because bacteria and microorganisms need water to survive and reproduce. They physically cannot grow in an environment that's dry. When bees make honey, they start with flower nectar, which is roughly 80% water. They pass the nectar from bee to bee inside the hive, each one adding digestive enzymes and fanning their wings to evaporate moisture. By the time the process finishes and the bees seal the cell with a wax cap, the water content has dropped below the threshold where virtually any microorganism can survive. Trying to grow bacteria in honey is like trying to grow a garden in the Sahara. Second is acidity. Honey's pH sits between roughly 3 and 4.5, which puts it in the same range as vinegar or grapefruit juice. That level of acidity creates a hostile environment for the vast majority of bacteria and pathogens, which prefer neutral conditions close to a pH of 7. Between the extreme dryness and the acid, honey is already one of the least welcoming environments in the natural world. But the bees added a third line of defense. During the honey-making process, bees introduce an enzyme called glucose oxidase from their salivary glands. This enzyme serves a very specific purpose. When it breaks down the glucose in honey, it produces two chemical byproducts. The first is gluconic acid, which further lowers the pH and makes the honey even more acidic. The second is hydrogen peroxide. Yes, the same hydrogen peroxide you might pour on a scraped knee to prevent infection. Honey is quietly and continuously producing its own antiseptic, not in large enough quantities to harm a person eating it, but in exactly the right concentration to kill bacteria on contact. This is the reason those ancient Egyptian wound treatments actually worked. The honey was slowly and steadily sterilizing the wound from the inside. Then there is the fourth property, which ties the whole system together. Honey is hygroscopic. That means it actively absorbs and pulls moisture from its surroundings. If a bacterium somehow lands on the surface of honey, the honey draws water directly out of the bacterial cell through a process called osmotic pressure. The bacterium essentially dehydrates and dies on contact. It is a passive automatic defense system that requires no maintenance, no refrigeration, no preservatives, and no human intervention. Put all four together: low water content, high acidity, continuous hydrogen peroxide production, and osmotic dehydration of any invading microorganism, and you have a substance that is hostile to virtually every form of microbial life on Earth. As long as the container stays sealed and no outside moisture gets in, honey will remain unchanged for centuries, for millennia, for longer than any civilization in recorded history has lasted. Modern medicine has circled back to what the Egyptians and Greeks knew intuitively. In hospitals across the world, medical-grade honey is now used to treat chronic wounds, burns, and surgical incisions. A specific variety called Manuka honey, produced by bees in New Zealand that feed on the Manuka bush, has become particularly valued because it contains an additional antibacterial compound called methylglyoxal that works even when the hydrogen peroxide is neutralized. Researchers have found that Manuka honey can kill antibiotic-resistant bacteria like MRSA, the superbug that terrorizes modern hospitals. Think about that. A substance produced by insects using a process that has not changed in millions of years is now being deployed against bacteria that have evolved to resist our most advanced pharmaceuticals. We spent decades building synthetic antibiotics, yet some of the toughest infections we face respond to something bees figured out long before we existed. Despite all of its chemical armor, honey does have one vulnerability: human carelessness. Add water, leave the lid off in a humid kitchen, or repeatedly dip a wet spoon into the jar, and you introduce enough moisture for wild yeast to take hold. That yeast ferments the sugars, and the honey transforms into something else entirely, which is actually how humans stumbled into one of the oldest alcoholic beverages in history. Mead, which is essentially fermented honey mixed with water, may predate both beer and wine. Evidence of mead production has been found in pottery fragments from northern China dating back roughly 9,000 years, making it a candidate for the oldest intentionally produced alcoholic drink in human history. The ancient Greeks drank it at festivals and rituals. Ethiopian culture developed a honey wine called teji that remains popular to this day. The Norse Vikings built an entire mythology around mead, believing that a magical brew called the Mead of Poetry, which had been crafted by dwarves from the blood of a murdered wise god named Kvasir, could grant wisdom, eloquence, and creative inspiration to anyone who drank even a single sip. Viking warriors believed that the halls of Valhalla flowed with endless mead served to them by Valkyries for all eternity. Across medieval England, Scandinavia, Poland, and much of Eastern Europe, mead was the dominant alcoholic beverage for centuries, long before widespread grape cultivation made wine accessible to anyone living north of the Alps. The English word honeymoon likely traces back to the medieval tradition of newlywed couples drinking mead for an entire lunar cycle after their wedding, a practice believed to promote fertility and good fortune. It was medieval Christian monks who kept the art of beekeeping alive through the long centuries when much of the classical world's accumulated knowledge was being lost. Monasteries across Western Europe maintained extensive apiaries, though not primarily for honey. Their real motivation was beeswax. The Catholic Church required pure beeswax candles for all religious services, believing that beeswax produced by virgin worker bees was the only material holy enough to illuminate the altar. This doctrinal requirement created enormous demand, and monasteries became the beekeeping centers of the Western world for nearly 1,000 years. The honey was treated almost as a secondary benefit. Monks used it for cooking, for brewing mead to sell at market, and for preparing medicines, continuing healing traditions that stretch back unbroken to the ancient Egyptians. For centuries, the basic practice of beekeeping changed very little. Beekeepers used woven straw hives called skeps, and harvesting honey usually meant killing the colony or destroying most of the honeycomb. It was wasteful and clumsy, but nobody had developed a better method. Then, in 1851, a minister and amateur naturalist from Philadelphia named Lorenzo Lorraine Langstroth made a discovery that transformed everything. While studying his own hives, Langstroth noticed something that other beekeepers had overlooked for thousands of years. Bees leave a very specific gap between their combs, roughly 3/8 of an inch. If the space is narrower than that, the bees seal it shut with propolis, a sticky plant resin they collect. If the space is wider, they build extra comb to fill it in. But at exactly 3/8 of an inch, they leave the gap open and use it as a passageway. Langstroth called this principle bee space, and he realized he could exploit it. He designed a wooden hive with removable frames, each spaced precisely 3/8 of an inch apart. Beekeepers could now pull out individual frames, inspect the colony for disease, harvest honey from specific combs, and slide the frames back into place without destroying anything. The bees would simply continue building on the existing foundation. This single invention, the Langstroth movable frame hive, became the foundation of modern beekeeping worldwide. Langstroth patented the design in 1852 and published a book called The Hive and the Honey Bee that became the definitive reference for beekeepers across the English-speaking world. Virtually every commercial beehive in operation today is still based on his original concept. His invention transformed beekeeping from a destructive seasonal harvest into a sustainable, repeatable, scalable agricultural practice. and it made the mass production of honey possible for the very first time in human history. By the middle of the 20th century, commercial beekeeping had grown into a major global industry. In the United States alone, millions of managed colonies were maintained. Beekeepers loaded their hives onto flatbed trucks and drove them thousands of miles across the country, renting their bees out to farmers who desperately needed pollination for almond orchards in California, blueberry fields in Maine, apple groves in Washington state, and dozens of other crops. The honey itself was almost secondary to this arrangement. The real money was in pollination services because without honeybees and the wild bees that assist them, roughly 1 out of every 3 bites of food we eat would simply cease to exist. Then, in the autumn of 2006, beekeepers across the eastern United States started reporting something terrifying. They were opening their hives for routine inspections and finding them empty. Not dead, but empty. The adult worker bees had vanished. The queen was still there, surrounded by a small cluster of young bees and plenty of stored honey. But the adult foragers were gone. They had left the hive and never returned. Nobody could find the bodies, and nobody could explain where they went. Within a single season, beekeepers lost roughly 30% of their managed colonies. Some operations lost over 90%. Scientists named it colony collapse disorder, CCD, and the search for a cause consumed years of research and millions of dollars in funding. What they eventually found was not a single smoking gun. It was a web of interconnected stresses, each one capable of weakening a colony and all of them hitting at once. A parasitic mite called Varroa destructor, originally from Asia, had spread to colonies across the globe. The mite feeds on the fat bodies of developing bee larvae and transmits viruses that cripple the immune system of the entire hive. At the same time, a class of agricultural pesticides called neonicotinoids, which had become the most widely used insecticides in the world, was found to impair bees' navigation and memory at doses too low to kill them outright. The bees could forage, but they could not find their way home. Meanwhile, monoculture farming was destroying the wildflower diversity that bees depend on for balanced nutrition. Chronic transportation stress from being trucked across the country weakened immune systems further. Climate change disrupted the timing between flower blooms and bee emergence from winter dormancy. Colony collapse disorder was not one problem. It was everything colliding at once. Decades of industrial agricultural practices slowly eroding bee health until the system finally buckled. The crisis has not fully resolved. Managed honeybee colony numbers in the United States have somewhat stabilized, but only because commercial beekeepers have adopted a brutal replacement strategy. They aggressively split their surviving hives each spring, dividing strong colonies into 2 or 3 smaller ones, and introducing new queens to rebuild population numbers before the next pollination season. It works on paper. Colony counts stay roughly stable from year to year, but the underlying health of the bee population has not recovered. Beekeepers are running faster just to stay in the same place. Winter losses that would have been considered catastrophic 20 years ago are now treated as normal operating costs. Wild bee populations face a grimmer picture. Solitary bees, bumblebees, and the hundreds of native pollinator species that do not have human beekeepers artificially propping them up continue to decline across North America, Europe, and parts of Asia. A study published by researchers in the United Kingdom found that 1/3 of wild bee and hoverfly species were in decline. Several bumblebee species that were once common across the American Midwest have effectively vanished from large parts of their former range. The ecological stakes are enormous. Bees and other pollinators are responsible for the reproduction of roughly 70% of the crop species that feed 90% of the global human population. If pollinator populations collapse permanently, the consequences cascade through the entire food system, far beyond losing jars of honey on grocery shelves. We are talking about almonds, apples, avocados, blueberries, cherries, cucumbers, and dozens of other crops that depend on insect pollination to produce fruit. And those grocery shelves have their own separate crisis. Global demand for honey now far exceeds what bees can naturally produce, and the gap has been filled by widespread fraud. Independent laboratory testing has repeatedly found that a significant share of honey sold in international markets is adulterated with cheap corn syrup, rice syrup, or beet sugar. Some products sold under honey labels contain no actual honey at all. In 2013, the United States Department of Justice brought criminal charges against two major importers for smuggling over $80 million worth of Chinese honey into the country through shell companies in other nations to evade tariffs. The honey had been ultra-filtered to strip out all pollen grains, making its geographic origin completely untraceable. Some shipments were contaminated with chloramphenicol, an antibiotic banned from food products in the United States. The investigation became known as Honeygate, and it exposed just how lucrative the global fake honey trade had become. There is a grim irony in all of this. A substance that has survived perfectly intact for 3,000 years inside a sealed Egyptian tomb can be cheaply counterfeited with a jug of corn syrup and a misleading label. But despite every threat, honey endures. It endures because it has always endured. Long before any human understood glucose oxidase or osmotic pressure or hydrogen peroxide, people recognized that this golden liquid was fundamentally different from every other food in nature. They watched bread grow mold, meat turn rancid, and milk go sour. And then they looked at a jar of honey sitting untouched on a shelf, unchanged after months and years. They treated it as something set apart from the ordinary world. They did not have the vocabulary of chemistry. They did not know about pH levels or water activity or enzymatic reactions. They just knew that honey lasted. And because it lasted, they gave it to their gods. The Egyptians sealed it in tombs beside their kings. The Greeks anointed their newborns with it and fed it to the dead. The Romans built estates around the insects that produced it. Medieval monks shaped an entire economy from the wax those insects left behind. And when a curious minister in Philadelphia measured the gap between honeycombs and found it was exactly 3/8 of an inch, he accidentally unlocked an industry that now helps feed the planet. Think about that for a second. A jar of honey sitting on your kitchen counter connects you backward through time to Howard Carter brushing dust off an alabaster jar in a pharaoh's tomb in 1922. It connects you further back to a prehistoric human clinging to a cliff face in Spain 8,000 years ago, bees swarming around their head and a basket clutched in one hand. It connects you further still to a Greek athlete eating honeycomb before a foot race at the ancient Olympics. The same substance, the same chemistry, and the same small insect doing the same quiet, extraordinary work it has been doing for millions of years before any human civilization ever existed. Honey does not just survive across the centuries. It connects us to them. It reaches backward through time, across languages, religions, and revolutions, to something older than farming, older than writing, and older than virtually everything we have built. And the bees that make it possible are still out there right now, visiting flowers and fanning their wings inside dark hives, turning nectar into something that refuses to die. Whether we protect them well enough to keep that chain unbroken is a question we have not yet answered. If this story of nature's eternal gold has changed the way you look at the world, please subscribe to our channel and like this video. We are dedicated to uncovering the history and science that often remains hidden. Let's protect the future together. Our next deep dive into the treasures of the past will be arriving soon.